In the previous episodes we learned how to set up the rotary probe and connect it to any motion controller. Today we'll show you how the rotary probe can be controlled and configured via the Modbus directly from your computer. Communication with the probe's control unit is handled via the RS-485 bus using the Modbus protocol. To connect it to your computer, you can use the USB converter included in the set. However, any other converter that provides an RS-485 interface can be used as well. The wiring is very straightforward. Both the control unit and the RS-485 converter have terminals labeled A and B. Simply connect the corresponding terminals between the control unit and the converter. Finally, connect the converter to your computer. With that, the wiring is complete. Go to the product page at topcom.cz and navigate to the download section. Here you'll find a link to download the application package, which includes the USB to RS-485 converter driver, the application installer, and a set of files for manual use if you prefer not to install the application. The application consists of a single executable file and a library for communication via the Modbus protocol. You simply need to copy the files into your target directory. The second link points to the application's source code on GitHub. If you wish to modify the application to suit your needs, you can simply download the source code. The next link points to the latest firmware for the probe's control unit. The firmware can be updated using the application. If needed, download the firmware package and save the included binary file to any folder of your choice. Now that we have all the necessary files, we can take a look at the individual functions of the application. When you open the application, the main control window appears. It is divided into three sections: status indicators that correspond to the LEDs on the control unit, a graphical representation of the probe position, and a section with control elements. First, you need to select the correct COM port and the Modbus address of the control unit. By default, the address is set to 1. Click the Connect button to establish a connection with the control unit and perform the initial status readout. You can refresh the data manually at any time by clicking the Read button. If you want to read data continuously, use the Pool toggle switch. Ongoing communication is indicated both on the converter and on the control unit. In continuous reading mode, the current status is displayed in the application window. Both input and output states are transmitted, along with a graphical representation of the probe's current position. Although the signals from the probes and sensors are combined into a single output, the Modbus interface allows you to read the status of each individual input separately. Just like the input states, the current states of the control unit's outputs are also transmitted. If the stop signal is activated by the probe guard function, this information is passed on to the master application. If the probe becomes blocked during rotation, the condition is indicated by the error output and is also visually represented in the application. In addition to status monitoring, Modbus communication also allows probe control. Clicking the button in the application performs the same function as pressing the physical button or the test button on the control unit. Just like the button function, you can also control the input that sets the probe position and the input that blocks the probe guard function. When an input is activated via Modbus communication, the corresponding LED on the control unit lights up. Now let's take a look at how to update the firmware in the control unit. Before starting the update, disable the continuous status reading mode. First, the control unit must be switched into bootloader mode. This can be done by pressing and holding the test button while powering on the control unit. An alternative method is to hold down the test or the external button for 10 seconds until the error LED turns on. Once the button is released, the LED will begin blinking. When the LED is blinking, the control unit is ready for a firmware upgrade. Select the binary file with the new firmware and confirm your choice. The firmware upgrade will be completed within a few moments, and the unit will automatically reset. Finally, you'll receive a message confirming that the upgrade was successful. The firmware upgrade is complete. You can now re-enable the continuous status reading mode and verify that everything is working correctly. Now let's briefly look at the configuration options available for the probe control unit. The configuration settings can be found under the Config tab in the application. Current parameters can be loaded using the Read Config button. The motor section contains parameters related to the probe's rotation process. The in and out section includes settings that define the behavior and function of the inputs and outputs. All parameters are described in the datasheet, which can be downloaded from the product webpage. The manual also includes a detailed description of each register used in the Modbus protocol. Let's now take a look at some useful features that can be configured. The first is the option to retighten the probe position every time the block signal is activated. This signal always logically precedes any measurement with the probe, as it disables the probe guard function. If for any reason the rotated probe becomes slightly loose or misaligned, this feature ensures it is always firmly repositioned into the correct working position. If the function is disabled, no retightening will occur. However, if this function is enabled, the probe is always retightened with a defined force for a specified duration whenever the block signal is activated. Another parameter configures the function of the up-down input. By default, this input is intended for automatic control. An inactive signal means the probe remains in the home position, while an active signal rotates it into the working position. You can also connect an additional button for manual control to this input. In that case, it is recommended to switch the input mode to toggle. The input will then behave the same way as the manual control button. Under normal conditions, the stop signal is not generated when the probe is in the home position. In this state, collisions are not expected, and this prevents false stop signals caused by probe or spindle movement dynamics. However, if for any reason it is necessary to generate the stop signal even in the home position, this function can be enabled via the appropriate configuration parameter. This brings us to the end of our basic demonstration of how to control the rotary CNC probe using a higher-level system via the Modbus protocol over the RS-485 bus. The application shown here serves as a reference implementation. You can download its source code and modify it to fit your needs, or use the provided documentation to create your own control module in other programming languages. It can also be integrated into machines and motion controllers that support Modbus communication. Thanks for watching this video. Next time, we'll focus on measuring the repeatability of the probe throughout the full rotation and measurement cycle. That's all for now. See you in the next episode.